Hello again. Today we're starting a new unit. The unit's title is Graphs of Periodic Functions. And a new Java update is available. That's nice. Alright, so today's lesson is on sinusoidal graphs. We'll be talking about what sinusoidal graphs are. They're basically the sine graph and the cosine graph though. Alright, so the unit is on periodic functions. Periodic function is a function which repeats, and sometimes you'll see cyclic behavior. Sometimes you'll be able to say that that graph is oscillating between two values. Out in the world, we see repeating or cyclic or oscillating behavior in things like seasons. Sometimes you'll see temperature displaying cyclic behavior, and even things like sleep patterns, other life rhythms. Alright, so for the sine graph, I'd like to take a look at this unit circle. This unit circle has a radius of 1 unit. Alright, so at this location here, 0 degrees or 0 radians. Well, back up a second. So this horizontal axis on our graph is the angle, theta, and then this vertical axis is the height of the point at that angle. So we see at 0 degrees or 0 radians, the point has a height of 0, and so the graph has a corresponding point right there. At this angle, which is 30 degrees, or pi over 6, we see that the point is this high, and so you can see that on our graph, the point should be that high as well. Same sort of thing with 45 degrees, the point gets a little higher, and so our graph gets a little higher. 60 degrees, or pi over 3, higher still, and then when the graph reaches 90 degrees, or pi over 2, the graph reaches its highest point. Now what is that highest point? Well, we said this is a unit circle, and so it has a radius of 1 unit, and so it reaches a highest point of 1, which we can see labeled on the graph right there. Now as you get onto the other side of the unit circle, the angle keeps growing, but the height decreases, and so now we are at a height the same as what we were at when we were at pi over 3, which is right over here. And we end up right there. Same thing with this point, 3 pi over 4. We end up same spot, and so forth. And so once we get to 180 degrees or pi radians, we get back down to 0. And so we'd eventually see this graph would, at pi radians, hit 0, and then eventually it's going to go down into negative territory to -1 and so forth. All that we saw in the last unit. This is for a refresher. So for the sine graph, to summarize, when we were at 0 radians, our point had a height of 0. When we got to pi over 2 radians, which was this 90 degrees here, we went up to a y value. Let me see, where is my cursor here? Alright, about right here. We got to a y value of 1. At pi radians, we can see that we got to a height of 0, and so our graph's value would be 0. We made it down to 3 pi over 2 radians down here, our graph would have a value of -1. And once we get to a full 360 degrees, we'd be back at 2 pi, which is the same location, or same height, as when we're at 0 degrees. And so we get back there. Now, of course, once we get past 2 pi, then this whole process is going to repeat. So these values in between are going to form a nice, smooth It's a decent curve that I drew right there. Alright, so once you get past 2 pi, this would repeat again with the same shape. So the domain is the set of all possible x values. Whoops, now we can see that this graph would continue forever to the left. It would be cyclic, it would go on forever. Same thing to the right. And so any x value would be possible for our domain, so the domain would be all real numbers. Negative infinity to infinity. For the range is a set of all possible y values. Now the highest that the y values get is 1, we can see, and the lowest that the y values get is negative 1. And it's possible for it to be anything in between. So we would say that the y values range from negative 1 to 1, and since it hits 1, we would say that it includes 1. Same thing for negative 1. Now the period. The period of the graph is how long it takes along the x-axis for your graph to repeat. How long it takes along the x-axis for the graph to repeat. So we can see that the graph, in a sense, starts at 0, 0, and it completes a cycle at 2 pi. At 2 pi, it's going to start out and it's going to do that same sort of shape of going up, down, and so forth. And so the amount of time along the x-axis that it takes to repeat is from 0 to 2 pi, which would be a distance of 2 pi radians. For the cosine graph, remember, is similar. Instead of starting at 0, 0, though, it starts at 0, 1. At 90 degrees, it hits 0. At 180 degrees, it hits negative 1. 270, it's back up to 0. And at 360, it is back up to 1. And then it repeats. So we have a graph that looks like this. In terms of its curves, it's basically the same as the sine graph. In fact, it is the same as the sine graph, except it's shifted over a little bit. Once we get past 2 pi, this whole process repeats. So we can see that, once again, its period is from 0 to 2 pi, giving us a distance of 2 pi. And its domain would again be all real numbers, same as sine, and its range runs from negative 1 to 1, same as the sine. Alright. Transforming graphs. Now, we're going to have a point rotating around a circle, kind of like we did at the top of the page. Except instead of this being a unit circle, this is going to be a circle of radius 3. So we'd have something like that. The radius, instead of being 1, will be 3. In such a situation, when we're at 0 degrees, the height of our point would still be 0. Now, one thing that you'll notice here is that this x-axis, which is supposed to represent angles, just has the regular numbers, 1, 2, 3, 4, and so on, instead of having pi on it, like we did in these graphs. So I'd like to point out for you is that these numbers, with pi in it, are just regular numbers. For example, pi is approximately 3.14. So half of pi would be about 1.57. 3 pi over 2 would be about 4.71. And 2 pi would be about 6.28. And so, scrolling down, when this point travels up to pi over 2, an angle of pi over 2, it would have a height of 3. So when it's at pi over 2, which would be about 1.57 right here, be about pi over 2, it's going to have a height of 3 units. Once it reaches pi, or 3.14, its height will be 0 again. So at 3.14, 0. Once it gets to 3 pi over 2, the height would be negative 3. So at 3 pi over 2, which is about 4.71, the height's negative 3. And then once we get back up here at 2 pi, or 360 degrees, height would be 0. So 2 pi would be about 6.28. 2 pi there. This was 3 pi over 2 here. So we got back to 0 there. And so this is a sinusoidal graph, a cyclic graph, and this pattern would repeat as we go to the right there, and would repeat if we went to the left as well. Next up, the concept of amplitude. The value in front of a sine function, which is sometimes the radius of the circle that you're spinning around, is called the amplitude. You can see in the last example, this graph had an amplitude of 3. Instead of going up to a maximum height of 1, you can see it's sort of vertically stretched to a height of 3 and a bottom of 3 as well, or negative 3. So often we use the letter A to designate the amplitude. And in a basic sine equation, if we have a coefficient in front of the sine function, then that A is our amplitude. So here is an example where we're using the concept of amplitude. Now we're using the concept of amplitude because instead of having a unit circle, we have a circle with a 3-foot radius, we can see here. The circle is mounted with a center 4 feet off the ground. So here's the center of the circle, and it starts out center 4 feet off the ground. The point closest to the ground is labeled P. Sketch a graph of the height above the ground of the point P. So this is height as the circle is rotated. Then find a function that gives the height in terms of the angle of rotation. We're going to skip that part that gives the height. We'll skip that, save that for later. Let's just start by doing the graph here. Alright, so let's say that, alright, let's say once again this graph starts at a 0-degree location. So we're going to start our graph at point P here. So at a height of 0, or at an angle of 0 degrees, we ask ourselves, what's our height? Well, it's starting out at basically the height of the center, which is 4 feet off the ground. So we'd start out right here. Now it doesn't say which direction that this circle is spinning. So I'm going to assume that it's going to rotate counterclockwise, because that's the normal way that we've been measuring positive angles, is by going counterclockwise. So then, let's think, when this point reaches an angle of 90 degrees right up here, 90 degrees, what would be the height? Well, at this point, the height would be 7. So at 90 degrees, which is pi over 2, we're at 1.57 on the x-axis, with a height of 7. So you get up to there. Then at 180 degrees, or pi radians, so 3.14, we're at a height of 4 again. So we go like that. Then at 3 pi over 2 radians, 270 degrees, we're down to a height of 1. 4.71, height of 1. Now I'm going to pause the video here and pick up in video number 2.